Hey guys, my name is Miss McCullough. This is Sam. Say hi. And we are going to go over solving equations with you for the EOC for algebra. This is the first session, and we hope that this helps you. This video is going to cover some sample multi-step equations similar to what you'll see on the EOC. It'll review important vocabulary words that we need to make sure we understand, and some algebraic properties. Now, before we begin, if you would like a little note-taking guide or a copy of this PowerPoint so you can follow along and take notes while we go through some of the problems, just click here. It will pause the screen, which is fine, and then when you come back, you can click play again. All right, this slide is just a reminder on some important words that we need to know. These are terms, meaning a term is separated by a plus or a minus. In this case, there's 3 terms. Remember that a number by itself is called a constant. Notice that I'm taking the minus sign with the 9. That's a -9. We also have variables here and coefficients. So if you hear the word coefficient in a word problem, it's really saying the number in front of our variables. This is just a great visual just to remember some of the properties that you'll need to know for your EOC. Commutative being one of them, so if you want to write that in your notes. And remember, commutative does not change changes the order. So I'm going to put change order. Remember, associative changes the parentheses. Distributive, you're going to use this a ton. Hopefully we already remember what to do there, but we're sharing by multiplication. And then identity is either adding by 0 to keep the same thing, multiplying by 1 to keep the same thing. So that's additive identity and multiplicative identity. All right, last thing to remember before we start doing some problems. What is the difference in simplifying the expressions 2x times 6x and 2x plus 6x? It's very important that we remember this fundamental concept for algebra and for what we do so we don't make silly mistakes. So remember that if you have 2x times 6x, when you're multiplying, you're going to multiply the numbers in front. In other words, 2 times 6, and that gives us 12. And when you're multiplying, you take your powers, which this is a power of 1 and power of 1, and you add them. So this is x to the second power. So when we're multiplying, multiply from numbers in front, add powers. Now that's very different than when you're adding. Adding is different. Adding, you can only add if they're like terms. And like terms mean they have the same variable with the same power. So if they do, you take the number in front, so 2 plus 6 gives you 8, and then you just attach the variable. It's a little bit different. So I just wanted to make sure that you remember those rules. When you multiply, you typically add your powers. When you add, you do not add your powers or do anything to your powers or exponents. You just make sure that they're like terms. Okay, this question is a word problem, and let's see what it says. And so the EOC will have this. They'll have a huge word problem here, like this specific example, and then notice it's going to say this. So let's look and see what this says. It says Vivian combined different amounts of white paint, blue paint, and green paint to make 145 milliliters of paint of a new shade. The amount of white paint was X milliliters. So they tell you, this is important. They tell you what X stands for, and we're going to need to remember that. The amount of blue paint was 10 less than twice the amount of white, and the amount of green paint was half the amount of blue paint. This is represented in the equation below. Okay, so what I want to point out here, a lot of times in the EOC, it's going to say this, and in standardized tests, this is represented in the equation below. And the reason I point that out is because sometimes when you read that huge word problem, it gets a little confusing. You get lost in all of the verbiage and all of the words. But if it tells you that it's represented in the equation below, then typically you have your equation and we're just going to need to solve that. All right, so the question says, what is the difference? So difference, remember, means to subtract. So I'm going to put myself a little note here. In amounts of white paint and blue paint that Vivian combined. Okay, so a couple of things here. We're going to need to figure out what X is because X represents the amount of white paint. Now I'm going to make one more note and then we're going to solve this. My last note is in my equation, I'm just going to put this is white paint because remember white was just X, white paint. And then the amount of blue paint was 10 less than. So if you look here, 10 less than, twice the amount of white paint. This is our blue paint, so I'm going to put blue. And then green paint was half the amount of blue. So I'm going to put this as green. And then I have my total. So that's just going to give me a little clue. Because right now the question is saying, hey, I want you to find X, I want you to find blue, and I want you to subtract them. Okay, so there's a lot going on in this problem. So let's first figure out how to solve it. So I'm just going to copy it down again. Now, I'm going to take the parentheses off of this one when I bring it down. And I'm doing that because those parentheses are there just for organization and I don't really need them. Now, if you look at the problem next to it, the 1/2, you will need it. Remember, this is called the distributive property you're sharing. 1/2 times 2 is 1x. 1/2 times negative 10 is negative 5. Notice I said negative 10 because the minus belongs with what's behind it. Okay, so now I have no parentheses. I'm one step closer. I've used the distributive property. Next line of work is to combine like terms. So I'm going to combine like terms. So x, 2x, and 1x are like terms. Remember, a like term has the same variable with the same power. So I'm going to combine these now. Notice there's no number in front of this one, so I'm going to put a 1. There's a hidden 1 there. 1 plus 2 is 3, and then so 3x. And then I've got this x over here that I'm going to combine it with, and that's 4x. So I have 4x. Now I'm going to combine the numbers by themselves. Remember, these were called the constants. When I put those together, notice how I took the minus sign with it. The minus belongs with the number behind it. Negative 10 times negative 5 is positive. Oh, just kidding. I'm multiplying. I don't need to multiply. I need to add them. That's negative 15. And then I can bring this down. So 4x minus 15 equals 145. Okay, so we have 4x minus 15 equals 145. So now we're going to solve this. So when I go to solve it, remember I draw a line through my equal sign. I need to move the minus 15 over first. So I do the opposite to bring that over and I add 15. Bring down the 4x. Bring down the equal sign. 145 plus 15, well 5 plus 5 is 10. 4, 5, 6, and 1. Okay, now I'm dividing. This is 4 divided by 4. So x here is 4d milliliters. Now, let's look and see what we found here. Remember, x in the beginning when we talked about this was the amount of white paint. X is the amount of white paint. So I have 40 milliliters of white paint. I want to point out a couple of things. Notice that they have this answer here. They put that there as a trick. Remember, the question didn't ask that, so they want to say, see, did you read it all? It says, what's the difference in the amounts? Difference, remember, means subtract. So we're taking our white and we're subtracting it from our blue. So if we have 40 white, let's figure out how much blue paint we have. So I'm going to do 2 times 40 minus 10. 2 times 40 is 80. Minus 10 is 70. So I have 70 milliliters of blue. So now all I need to do is I need to take these two and I need to subtract them. 70 minus 40 is 30. So I have 30 milliliters difference So my answer really should be A. All right, this question says, Guy and Jim work at a furniture store. Guy is paid $185 per week plus 3% of his total sales in dollars X, which can be represented by G of X equals 185 plus 0.03x. All right, remember what we talked about earlier. It gives you all those words, just to say this. So I'm going to make myself a little note. I'm going to dissect this as I go. And it looks like Guy's equation is G of X equals 185 plus 0.03x. Okay, now what I'm going to do is I have Jim. Jim is paid $275 per week plus 2.5% of his total sales in dollars X. So this is going to be important too for both of them. Our sales represents our X, which can be represented by f of X. So I'm going to put Jim. And I know that Jim is f of X equals 275 plus 0.025x. Now, this question is saying, determine the value of X in dollars that will make their weekly pay the same. Their weekly pay the same. Now, anytime you see the word the same in a word problem in math, it typically means that you're setting something equal to something else. So we're going to take our two equations and we're going to set them equal. So 185 plus 0.03x equals 275 plus 0.025x. Okay, so here's what we've got. Now what we want to do is we want to move the variables all to one side and the numbers to the other, and it does not matter how you do this. What I suggest you do, or what I like to do, is I move the smaller x over first. So notice I'm taking the plus sign with it because it belongs with what's behind it. I'm going to move the 0.025x to this side. So I do the opposite, which is to subtract. It's the opposite of a plus sign. Or a positive number, we do the opposite here. Putting it right underneath that variable. And then I'm doing 0.03 minus 0.025. And that gives me a positive 0.005x. Now I'm bringing everything else down. So I have a 185 here. That's positive. That's equal to 275. All right, my next step is to get all the numbers in blue on the same side. So this is a positive 185. I'm going to bring it over, which means I do the opposite. I subtract 185. When I do that, cancel, cancel. I can bring this down. Getting closer. All right, so I have 275 minus 185. That gives me 90. Okay, my last step, if you look here, this is 0.005 times x. I do the opposite, which means I divide. Cancel, cancel. 90 divided by 0.005 gives me 18,000. It's a big number here. Now let's look at and see what the question's asking us to do to see if we're done. It says determine the value of x in dollars. So it's important that we put here a dollar sign because x represents the amount of dollars. And let's be more specific. That will make their weekly pay the same. So $18,000 is when their weekly pay is the same. So I'm just going to put weekly pay is the same. And remember, that's a furniture store place. So when they sell $18,000, they're going to make the same amount of money. Okay, this one's just a reminder on how to solve an equation with multi-steps. So we've got some distributive property here and some moving things over. So let's go ahead and do that. First step here is to use the distributive property and get rid of those parentheses. Remember, you take the number outside the parentheses, share it with inside by multiplication. So 3 times 2 is 6x. 3 times, this is like a minus 1 or negative 1, minus or negative 3. Okay, so let me write this whole thing out. So now I have 6x minus 3. I'm going to bring everything else down. Okay, now what I want to do is I want to make sure that there's nothing I can't combine on each side. So if I look on the left side of the equation right here, I can combine my constants, which are my numbers by themselves. Notice I'm taking the minus sign with what's behind it. That's what it belongs with. A minus 3 and a minus 10 gives me a negative 13. Bringing down, bringing down. Now remember, an equation is balancing, so it's saying do both of these sides equal the same thing. Now I want you to notice something here. Notice that this is a 6x and this is a 6x. That's the same thing. It doesn't matter what x is. If you plug in 1 for x, 2 for x, 3 for x, it doesn't matter. You're going to get the same thing here on both sides. But the difference, if you look here, is that this is going to be subtracting a 13, while this is going to be adding an 8. So I want you to think about that. If you plug in something for x on both sides, will it ever give you the same answer if you're always going to subtract 13 on this side versus add 8 on this side? Now, when you think about that, that will never happen. You can't take 6x and minus 13 and then take 6x and add 8 and get the same thing, like ever. So right away, we know our answer is no solution. And you know that because the x is the same and the constants are different. Now, if you didn't notice that and you kept solving, let me show you what that would look like. Okay, now next step, if you were to continue solving, is to move all of your variables on the same side. So I'm going to move this one over here. I'm going to do the opposite, which means subtract. And that gives me 0. Those cancel, bringing down what I have left. And then I'm going to stop and look. All my variables canceled. Right now it tells me that negative 3 is equal to 8, and that's not true. So in the case that this happens, that means there's no x value that you could plug in for x in this equation and it be equal or balanced on both sides. Okay, let's review really quickly the algebraic properties that we may need. This is a sample question that what it could ask you to do to find the rest of this little proof or justification. So that if you look, it says some of the steps in Reyes' solution to 2.5 times 6.25x plus 0.5 equals 11 are shown. Drag the correct reason to the box for line 4. Okay, so in an EOC question, it could say something like drag, where you're going to actually have to click on these and drag them into the spaces. We're going to go ahead and just kind of solve this so you can see what it looks like, and it gives you an idea. So from step 1 to step 2, what are we going to do here? You're right. What we should do is we should multiply. That's called the distributive property. So that does 2.5 times 6.25 equals 15.625x. Now I'm taking this and I'm sharing it here. 2.5 times 0.5 is plus 1.25 equals 11. Now this is just like what you normally would do. It's just written in this is called a 2-column proof, which you're not familiar with entirely yet, but that's what this format is called. Okay, so what did you use to get that? Well, we said at the beginning, you used the distributive property. So if you had to actually drag your answers, you would put distributive property here. You would drag that response here. Okay, now 3 tells us we're going to use the subtraction property. Even if you didn't look at that, you would see that you probably want to subtract the 1.25 from both sides. So let's go ahead and do that. Fill this in, see what we have left. So I'm doing 11 minus 1.25, and that's 9.75. That's the subtraction because you subtracted the 1.25. All right, our last step here is we want to get x by itself. So normally we do that. If this is multiplication, we do the opposite, which means we subtract. I'm sorry, not subtract, divide. What am I saying? We divide. Now we don't really need to find this answer. I will for you. which I'm getting kind of a weird answer, or decimal. But keep in mind, this question is saying the reason. We want to know, what did you use? And we divided, so that's called the division property of equality. So this answer would have been this one for step 4. Okay, this is our last example in terms of properties. We want to end with properties, just kind of a review. This is a good example of what it could say. It could say type your answers or provide the definition. This one says a student solved the equation 3x plus 2 equals 9 minus x as shown below. Assume there's a value of x that satisfies the equation. So all that means is there's an answer. We found an answer for x that could work to balance both sides of these equations. All right, so let's kind of see what we did to solve it. So what did we do from our normal equation to a? Now they have a 4x, and we don't have a 4x in our normal equation. Remember what I told you when we did a problem with variables on both sides? I usually pick my smaller, in this case my minus or my negatives, and I bring them over to the other. So that's a smaller x value. I'm going to bring that over. If that's negative x, I'm going to add x. And when I do that, I get 3x plus x, which is 4x plus 2 equals 9. Notice that's kind of what they have. That is exactly what they have there. So justification means, well, what did we do? Well, we added. We added x. So that's called the addition property of equality. This may be a drag and drop. It might give you something to choose from. Okay, now let's look at the next step. From A to B, what did they do? Well, this is 7, so they took this plus 2 and they subtracted it, which is what we normally do. So if we normally do that and we subtracted, that would be called the subtraction property of equality. Getting a little messy over here, my apologies. All right, what did we do last? So if we look here from B to C, we divided by 4 because we want to get the x by itself. So that is the division because we divided. So when you ask yourself, what did I do? And you can say, well, I divided. That tells you the property you used, division property of equality. And all that fancy property of equality means is you're dividing both sides on the equal sign. Okay, so we just picked a couple, went through them. Hopefully that helped refresh some ideas and reminded you what to do to solve equations and look at some of those properties. If you need extra help, feel free to click on the Need Practice here. That will take you to an online site with a couple of questions with the answers. So hopefully that is helpful. Make sure you include your name there. If you have any questions for me or any comments, please feel free to give me an email. You can send me an email by using the link below. Good luck on your EOC. I hope it goes well. Let me know if you need anything.